Okay, continuing with section 6.2, let's continue with the formulas. So far, I introduced what your cosine value is, and I said in the last video that that would simply be your horizontal leg on the triangle you develop, whether it's a 30, 60, 90, or a 45, 45, 90. This leg represents the x value, also known as the cosine. The vertical leg represents the y value, also known as the sine. So now there are other trig functions. There are certain ones that are related to sine and cosine, and they are related in a reciprocal fashion. So when you're being asked to calculate all the trig values for a particular triangle, I would do sine, cosine, and tangent first, and then just flip over, because that's what reciprocal means. These are all reciprocal pairs. So sine and cosecant, if you want to write this out just so you know how to say it, we always abbreviate it though. That stands for cosecant. This one stands for cosine. This one stands for sine, these abbreviations. This one stands for tangent. You probably know remember at least that much. This one stands for secant. This one stands for cotangent. Anyway, I've arranged these for you in reciprocal pairs. So if you find the sine, see how the definition is y, or in other words, y over 1. If you just flip that definition over, you have the definition for the other one. So if you have the answer for this, I would just flip it over and you got the answer for two of them. With respect to cosine, secant is its reciprocal partner, its reciprocal cousin. So if the definition for this is x over 1, flip it over. In other words, form the reciprocal and you have 1 over x. So you could just take the answer, flip it over. Now, sometimes when you flip these answers over, you're going to need to do what I just did when I was showing you the 45, 45, 90 triangle in the last video, and how I was showing you how to solve for the leg, and you got a radical in the bottom. You can't have radicals in the bottom, so you'll have to rationalize throughout many of these answers. This is just another picture for you where you have a rotating arm, one that always stays fixed to the x-axis, which is called the initial side. And again, these triangles get created by going from the dig-in point, right where you dig into the circle, and traveling to the nearest x-axis. Now, I don't know what some people or some students hear in their head, but on the test, I'll get a few people that'll travel over to the y-axis. All your answers will be the opposite of what they're supposed to be. Do not go over to the y-axis to make your right triangle. It's always either drop down or you'll be traveling up. You'll be traveling either down or up to get to the x-axis. Make your way to the x-axis, and then you'll have the y, the x, and the radius of 1, because again, you're studying the unit circle. Okay, this is nothing more than the Pythagorean theorem, and mostly everyone remembers that because you use it in all math classes, not just in geometry and trig. So this is leg squared plus leg squared is equal to hypotenuse squared. That's your Pythagorean theorem. You have to use that to find the missing pieces in a right triangle if you don't know any of the angles. If it's not a special right triangle, then you can use your special right triangle formulas and automatically know what the values are regarding the sides of the triangle. That does not mean you're going to know the trig values, though. You have to have these formulas memorized to get the trig values. So this is sine, just y. And, later on, we're going to study placing triangles inside circles where the radius is not 1. This 1 that you're seeing right here, that's the radius. So all of these formulas can be rewritten as y over r, x over r. When you start getting into circles, you'll do a little bit of that where the radius is not 1. But the one you're seeing here, that's the radius. So y over r, x over r. And then maybe you can memorize that of these reciprocal pairs. This pair seems to be a little bit hard for students to memorize, and so does this one. Just remember, one starts with an S, one starts with a C. Same thing here. One starts with an S, one starts with a C. This pair is easy. Tan and cotan. It's kind of natural that those go together as reciprocal pairs. So then here, this you don't use the radius at all in the tan and cotan values definitions. It's just y over x for tan. Flip that over, you have the answer for cotan. Okay, now we actually get into the problems. You can actually do 1 through 3 at this point, and that's why you need the theorem page in front of you when you're taking notes. And you could also do number 6. Okay, so let's get at that. Grab your homework outline from my math lab. Let's answer some of these questions. Okay, so in the first one, they're just trying to get you to use Pythagorean theorem. So it says you have a hypotenuse. They just mentioned this right here. Hypotenuse is C. The legs are A and B. Put the A wherever you want, the B wherever you want. But the C is the hypotenuse. It has to be across from the right angle. So it always goes hypotenuse squared, because they're not always going to use A, B, and C. Therefore, you need to know a generic way to remember the Pythagorean theorem. So hypotenuse squared is equal to leg squared plus leg squared. And that would be that. Okay, that's this one. And number 2, let's say you have a point on a circle, any point, whether it's on a circle or not a circle. If you're in a 2-point system, Cartesian system, XY system, that you have an X and a Y coordinate. So they're saying that you are traveling along the rim of a circle and you stop at a point, which we're going to call X and Y, but you stop in quadrant 3. Let's start getting used to spinning around the circle and not necessarily stopping at quadrant 1, because you're going to be asked to stop in any of the 4 quadrants. So let's see, I'll use that as my x-axis. And you don't have to draw the circle, but just keep in mind that you're inside a unit circle. You can wrap the circle around it if you want to. It's just be easier to draw without it. Okay, so here I go. One side stays fixed here while the other leg rotates. So it's going to rotate, rotate, rotate. They told me to stop in quadrant 3. So that means here's your rotating arm right here. And yes, wrap the circle around it if you want to, but it is not the most important. We already know that this means radius is 1. And I want you to be very clear on the fact that this rotating arm would be the radius if you chose to draw the circle around it. Okay, so why don't you go ahead and label that. Right where this thing stops rotating, no matter how long you decide to make it, just make your way to the x-axis, not the y-axis. Okay, remember the leg that goes up and down will be the y. Leg that goes horizontally will be your x, and that's called r. And you are just given a bunch of definitions with respect to x, y, and r that were all defined using x, y, and r. Okay, so it says if the x is negative 1/2, then what is the y value? Okay, so you're in a 30, 60, 90 here. If this is 1/2, then that means, and you see that the hypotenuse is double that. This number is double that one. The radius is always, by the way, the radius, don't get confused by the negative. The reason that the x is negative is because you're over on this side of the y-axis. X's are always negative. Things that cannot ever be negative, the r value is always positive. This is the way we say that a certain value is always positive, by saying that it's greater than 0. So the r value is always going to be positive. So disregarding that negative, do you see that this number 1 right here is double that? You have to be in a 30, 60, 90. And always across from the 1/2 is the 30-degree angle. Across from the other leg, the y value is the 60-degree angle. This is also known, as a review of what I did on the previous page, the short leg. The short leg will always be 1/2. The hypotenuse will always be double that and always positive. And across from the 60 will always be the long leg. and the long leg will always be square root of 3 over 2 when you are in a triangle with a radius of 1. Okay, now with regard to where this triangle is, you're in territory where x's are negative, but they flat out told you that the x was negative, but you're going to have to think about this y value yourself. You're in quadrant 3, and y values in this quadrant are also negative. So that'll be your responsibility to attach that negative yourself. Some of the negative signs they'll give to you, others you'll have to think about yourself, which they're asking you that value. And my math lab will mark it wrong if you can't get the negative correct. Okay, number 3. Let's see. For any angle theta in standard position, that means the angle at the center of the circle. Maybe put that in your notes. This means theta is at the center of the circle. Or you could say it's at the origin. That's what a central angle is, and that's what standard position means. It's 2 different ways of saying the same thing. Let P be a point called X and Y. In other words, that has an X and a Y coordinate. On the circle where x squared plus y squared, that's just the Pythagorean theorem, because you're also going to be in a triangle, a right triangle, even though you're in a circle. So then it says, what is the sine and what is the cosine? Okay, let's try and put all this stuff in a diagram, because it's kind of hard for students that are just starting to understand what the question is asking. But when you see it in a picture, it's easier to grasp. Okay, so you're in a circle. I think it's important to draw it for you this time. Your angle at the center is going to be called theta. You can't have an angle unless you have a rotating arm. So now let's see. Did it say what quadrant we're in? It does not. Okay, so if it doesn't say that you're in any quadrant other than quadrant 1, it doesn't make mention of that, then draw your picture in quadrant 1. So we're going to let this be theta. We're going to drop down to the nearest x-axis from the point where our rotating side just dug into the circle, drop down to the x-axis. That'll give us a y, an x, and an r value of 1. So then it says, what is the sine value? They're just having you derive the formulas, which you've already been given on the previous page. So you can memorize them, or you can understand. You could try to attach some form of understanding to what you're doing, rather than memorizing everything. So I think that's probably a good idea. I mean, you could even do SOHCAHTOA here. When you probably remember that from geometry. A lot of geometry teachers use that. This is like a little saying that has all the formulas in it. You could go the sine value. This would be the sine value of whatever your angle is at the center. And then this letter and this letter is actually the formula. All of these formulas are fractions. So opposite, that's what O stands for, over hypotenuse. I might as well drag this in. So the sine of theta using this picture, now whatever the angle is that they mentioned right after the trig word, the angle at the center, you need to stand right there so that you get what opposite and hypotenuse is correctly, specifically opposite and adjacent. Okay, so if you're standing right here, the side opposite to you is called y. The hypotenuse, yes, I put a 1 on there, but in general, it's called r. R is what we use for hypotenuse. So they ask you, what's the formula for this? Y over r. When they ask you what's the formula for cosine, it's cosine with you standing on theta. According to this SOHCAHTOA, cosine is equal to adjacent leg over hypotenuse. Opposite and adjacent refer to the legs. Hypotenuse, you know which one that is. Okay, so opposite would be across from you. Adjacent would be underneath you, kind of like holding you up. That's this x value. And then the hypotenuse is just called r, because they want you to give the formulas in terms of these variables x, y, and r. So this first one, you're filling it in with y over r, and then the other one you're filling it in with x over r. Okay, next video.